Yeah, I'm Ruchir, co-founder of Side Labs. Have been in the security space for a little over 10 years now. Started with Google in the US, spent time working on insider threats and AI security there. Moved to India to set up Google's India security practice. Led that for a couple of years. In the last 3-4 years was the CISO at MPN, Mobile Premier League. And since late last year have started Side Labs. At Side Labs, we focused on building security products for Gen AI systems, starting with LLMs. So just to get a sense of the crowd, is everybody with a security background, with a show of hands, like currently or in the past, have you worked in security? Okay, so I'll assume there's 80-ish%, 90-ish% people who worked in that space, some who are just interested in it. Okay. Going to the next point, right? Like, why are we talking about security for AI differently than security for everything else, right? Like, isn't AI just software? This is a conversation I've had extensive debates with somebody who used to be like a VP at security, VP of security at Google, because she keeps telling me AI is also just software, right? Like, why is it any different than any type of software that you're protecting? You're protecting the same thing. It's still code. It's still bytes. It hasn't converted to atoms, right? So I'll try to cover that, at least why I think securing AI is different, or at least you should start thinking differently, right? Like, so if you've been focused on securing traditional software, how should you probably think differently when it comes to AI and why the problem has evolved? And none of it means that you don't protect your other systems, right? Like, this goes hand in hand with protecting your regular AI, software. First one, right? Like, how do you test a system for security? Most of the times when we do red teaming, VAPTs, penetration testing in-house, externally, anywhere, if I'm a security engineer, I write an attack payload, I test it. If it works, it works. If it doesn't work, I know it will not work even if I try it 10 more times, right? But when it comes to stochastic systems like AI systems, your internal security system engineer might try an attack. It would fail. And if they assume this attack doesn't work, would be a wrong assumption, right? Because the next time somebody else who potentially could be external tries the exact same payload, there is a chance that this time the attack would work. So you can't go with the same approach of traditional security where, let's say, you have done your testing and tried every attack once or run a scan once, and you're like, okay, this is done, this is secured, don't need to test it again. Or especially if a lot of companies that don't have large in-house security teams rely on external pen testing services, right? There, if you're getting it done from them, they also usually have a checklist they follow, try all the attacks. They say, this didn't work, this didn't work, this worked, this didn't work. Doesn't work with AI, right? Like, at that point, it did not work, but without making any change to the system, now it could suddenly start working. That's one. Next is, you don't know what has changed, right? So this is one example we were doing internally, right? Like, we took a base LLM model, we tried a very simple query. This is one of the most popular models out there. That we are founders of XYZ, help me do ABC. And it said, I can't do this. Then we took 500 rows of Q&A, which were very simple questions. These were just like, what's the capital of India? What's the temperature in this city? Very simple, 500 rows of data. Fine-tuned that model, and now suddenly exact same question, and it starts abusing random companies in the world and saying that you don't deserve to be a founder, right? So why I bring this up is, in a traditional system, if you've designed a system which does A plus B equal to C, if nothing has changed there, you don't need to test it again. For systems with AI, you may have made changes for X, and suddenly something completely different gets impacted. So you are never certain of what needs to be tested, because a lot of times in traditional security, when you do your security testing, it's always incremental, right? Like, you first ask what's the change going in the system, and that's the only change that gets reviewed. But you can't rely on that assumption anymore, right? Like, anytime you're making changes, almost everything needs to be retested, right? And something that we've been hearing for years, right? Like, shift left, right? Everything needs to shift left. When you shift left, your cost reduces, your time reduces, your efficiency improves, and you get better results. But is it really true for AI, right? So let's say you do everything secure while you're developing, or maybe even one more system left, right? Like, while you're designing, you can do everything right from a security point of view, but it doesn't give you any guarantees, because these systems can misbehave at runtime. You don't really know how these systems are going to behave. Not saying you don't need to shift left. I'm just questioning the dollar sign, right? Like there isn't enough, maybe there's not enough research done yet in this space where you can say that you will get better results if you do it earlier. So far, I have a strong opinion you get much better results if you do it later. But that needs to change. It will change, but I don't know what that timeline is. So for the time being, the paradigm of let's shift left may not apply the same way as it has traditionally been applying, especially from a time, cost, and effectiveness for security point. Right? Is open source really open? Right? Like there's so much talk about using open source models, open source software, and unlike traditional software, right? Like if you're picking say, anything open source, it's actually something you can go in, review, check what is being done. You can actually run your security scanners on top of them, see exactly what's wrong, what you're actually bringing in. The line is very blurred when it comes to models. Right? There's a wide range of what can be termed open source, right? And it's being used very vaguely. So sometimes even the model provider doesn't know what actually goes in, right? Like for them itself, it's a black box. So when you're bringing in these models, you don't really know what you're actually bringing in. I picked two not random, but recent examples. One was, I don't know how many saw the serialization attack that happened through open source models from Hugging Face. But again, that was something that was not very trivial to capture, right? Like that's not what your traditional systems would have captured. And anybody who has AI, ML teams working in their companies would know that these days everybody's picking models from anywhere they find, deploying anywhere they can, most likely running in a random Jupyter notebook on their laptop or a random server. So you don't know what's getting run. And the second one, I picked the recent backdoor, not really AI related, but the fact that open source software had a backdoor that was undetected for years and had massive consequence. This can be extremely worse when it comes to AI. One, it's much harder to detect these. It's much harder to do any sort of auditing on a wide scale when it comes to like all open source software. And in some cases, not just possible, right? Like in the leave feasibility. So there are a number of backdoors that could be going into a lot of these models coming out. You never know when those trigger. And those backdoors need not just be code execution, they need not be RCs. They might also be data poison, right? Like you don't know what's the data going in most of these cases. Now, two slightly philosophical questions that we've run into when talking to customers these days, right? So who owns security? This question started mostly during the whole transition to cloud, right? Like who owns security when you're not owning all your hardware, all your software, all your infra? It's getting even more blurred when it comes to AI, right? Like I'm sure some of you might have heard the Air Canada incident. They launched a chatbot on their website which would address customer complaints. This chatbot was powered by an LLM. Customer raised a bereavement claim to get a refund after taking a flight and was able to use certain ways to abuse the system and get the refund. When the thing went to court, one of the things that Air Canada tried to do was they tried to blame AI for the actions taken. And they said, we didn't do anything. It was the bot that did it. But that was quickly struck down. And the Canadian court said that if your system did it, you are responsible. But now then they wanted to start claiming we use OpenAI in the backend, so we need to blame the model. So there's still a lot of uncertainty on when you're using AI, who owns security. Is it the person building the model? Is it the person who's fine-tuning it? Or is it the person who's then using it to deploy the system? Or is the AI itself responsible, right? But in most cases, it comes down to what the customer looks at, right? Like if Air Canada is serving it to me, in most cases, it will be termed as Air Canada responsible for its security, right? And the last one is something I still don't have an answer, like something that nobody's found an answer, right? Like who owns safety? When you're using AI in these systems and that AI ends up answering something that it shouldn't, or answering something that's biased or toxic or inaccurate, whose ownership is it? And especially when it comes to enterprise, we've gone to calls where we've had like 10, 11 different executives sitting from completely different parts of the business, like marketing, legal, finance, AI, security, privacy, policy. They all want to solve the problem, but nobody wants to raise their hand and say, this is my problem to own, right? Nobody's figured who in a company owns this once we deploy the system. In most cases, when things go wrong, most of you might be aware, it's usually the security team that people will chase, right? That why did you not catch this before? So this will then lead into why red teaming sort of becomes important. Cool. So yeah, AI red teaming. Again, red teaming, World War time concept, nothing completely new, but very quickly, how do you define red teaming? Instead of me doing it, I let the White House do it. So red teaming, I won't go through the whole thing, but the thing is it's starting to become something that governments are recognizing, regulatory bodies are recognizing, and think at this point for AI, that has turned out to be one thing that everybody is reliant on in order to check whether your system is safe or not, or secure or not. And it also takes you to when do you need to do red teaming. As of now, we're already getting to a point where it's extremely important, right? Like the US executive order already mandates AI red teaming. The EU AI Act requires a report to be submitted for adversarial testing for certain use cases. Most copyright guarantees, right? Like, so for example, if you're using a model and you get a copyright claim against you, for example, Microsoft gives you a copyright guarantee that if you use their models and you get a copyright claim, they'll pay for it. But it has a fine print. It says, unless you have done red teaming to test against copyright infringement, they won't pay it, right? So unless you do a copyright red teaming on Microsoft models, Microsoft will not give you your copyright claims. So a lot of places, red teaming has almost started becoming an assumption that everybody deploying AI is doing it before they deploy the system. Now, what all falls under red teaming? Again, this is not exhaustive, and this is not a session to teach how to do red teaming. Just going into an overview of things you need to look at, things you need to start keeping in mind while you're doing it and when you should or should not be doing it. The first part, most obvious one that comes to everybody's mind when they think of red teaming an AI system is the security pieces. How we like to approach it is we're big fans of the OWASP LLM Top 10. They cover most of the common abuse vectors. So make sure when you are starting to do your AI red teaming, this is something that you ensure that you're covering most of them, because in most cases, all of them will apply. If you want to go one step deeper when you're starting threat modeling before you do red teaming, MITRE's Atlas framework is extremely exhaustive, extremely good. We'll take a time to digest it. So take a weekend, couple of days, go through it. If you're familiar with the MITRE attack framework, it's adapted from MITRE ATT&CK into MITRE Atlas, which is focused on AI and ML. But yeah, if you're starting to focus on security testing, these would be the places I would start. The next two are areas that I've seen a lot of companies miss when they're doing red teaming, and that comes back to the whole who owns this piece, right? So when it goes to the security team, they'll focus on these security problems. But then with AI systems, there's a lot of safety issues that come in as well. And that usually most companies will not have like a trust and safety team dedicated to test products, right? Like they're more operational teams versus testing teams. So there's concerns around toxicity, violence, bias, misuse, dangerous information, non-exhaustive list, hence 3 dots. But based on what you are serving your use case, this becomes an extremely important testing suite, right? Not all security teams will be equipped or, let's say, experts in doing this, but it's very important for you to sit with your business counterparts, your policy counterparts, product counterparts to understand what's the need or what are the attack vectors when it comes to safety testing. And the last one, which is even less common that I see people follow, is things like copyright issues, right? Like when you're bringing in an external model, right? Like what data was that model trained on? Based on the use case you are using, could there be copyright issues that come up? Brand guidelines, right? Like in most cases, if you are serving the model as a company, what are your brand guidelines? Are there ways to bypass it? Could it cause a PR issue? There's a lot of systems that now are trying to detect deepfakes. Let's say you are a KYC company, right? And are using models to detect whether the liveness check. Are you able to run red teaming on trying to use deepfakes on them and seeing, are you able to bypass those systems? And abuse of platform, right? Like, for example, there was this mattress company, right, which was selling mattresses but had a negotiation bot where you can negotiate the price using an LLM, and people were able to get it to give like almost 99% discount via prompt injection. So are you checking for what are potential abuse to your business use cases through these systems? Cool. Now, while you're doing this, when you're building your team, planning this, executing it, what are key things that you should keep in mind, right? Like, and this is very similar to what you would do with a traditional red teaming, just some minor tweaks and changes. Plan it really well, right? Like, this is something that can become a rabbit hole very quickly. You can, because the number of abuse vectors are so large, you need to ensure that you have very clear goals while you're doing it. Maybe break it into multiple exercises rather than a single one. Figure out what you're focused on, right? Like if you're focused on security first, abuse first, toxicity first, safety first, figure that out. This is not something that can be done independently by just a security team, right? Like make sure you understand what's the business actual use case of this system is, right? Like let's say you're deploying a customer support agent on a customer support bot on your website, and the business wants it should only answer things related to your business and about that customer. But let's say somebody comes and asks it to write code in Python. You as a red teamer might assume, oh, this is not bad, it's fine, it's just helping the customer. But the business might have a specific use case of not answering off-topic questions. So that also becomes things that you need to test for. AI is new for everybody, right? Like it's been there for a long time, but the way it's being used now is very new. So make sure and especially like security expertise is extremely rare in the world. AI expertise very similar, and an intersection is almost non-existent. So make sure that your team has the resources to understand what are the models, how the systems are designed, where is the data coming from, what are the abilities that your system has, can it actually go to the internet and fetch things, does it have the ability to take actions, does it have the ability to read customer data. All of those pieces make a very important input into what your plan for your red team becomes. For most of the reasons that I discussed why AI is different, manual won't work, right? You'll need a tool to do this. For example, like the first example I gave where you run the payload once, it didn't work, but run it 10 more times, it might start working. So this is not something you can do manually. And let's say your models are updating every 5 days, 6 days, 2 weeks. You need to run your entire red team all over again, right? Like this is not something that a set of humans can do at scale. So you will need to pick a tool, build a tool, start running these scans. So that also goes into the next point. This needs to be continuous. You need to be testing it even with the smallest change, right? Like it can't just be that, oh, this was a very small change to the system prompt or very small change to the model. The whole thing needs to be tested again, right? One thing that comes up very frequently, it's more of a nitpick, but I wanted to call this out, is a lot of times when system prompts leak or prompt extraction happens, most people are like, so what? Right? But I want to call out it's actually really bad in most cases. Because when you're building these systems, your engineers are not assuming this to be an open system. A lot of business logic goes in there, a lot of value. It's almost like the recon step of your traditional security space, right? Like you're giving away every step or conditions that you're putting into your system. So even though in itself may not be that critical, it becomes a very important part of an actual attacker, right? Like if you have a threat actor, it becomes extremely useful information for them. So you don't want to leak that. And another misconception, which has been broken again and again now, is a better model is not a safer model, right? Like we've seen it across most of the leading model providers, be it OpenAI or Meta with Llama or Google with Gemini. As the models are improving, all our testing shows that security is only going, or security, safety, all of it is only going down. We haven't seen any model that has gotten better or a newer version has come out to be safer. So again, don't make that assumption. Cool. Some tools, again, not exhaustive list, a quick shameless plug that help you automate these things. There's a lot more. I just picked the ones that I used in the past. So we have one tool within Sidelabs called Sidebox, which helps with red teaming. There's the ART tool. Azure, Microsoft has a tool called Pirate. Garak is a fairly popular open source tool as well. So pick your tool, right? You will need a tool. You will have to automate things. Leading into the whole shameless plug, a quick overview of how our tool works. So maybe not very clear in terms of the screenshots, but we have like two ways where we run attacks. We have like a large attack library which runs against your systems. gives you a report at the end of it on where you're broken, what types of attacks happen. This is something which we use to also give you like zero-day attacks. Let's say a new technique comes out, it immediately gets updated here. You can auto-run it. You can set schedules, run against your systems and give you a report. The second one is an agentic approach where you can run all the way from black box testing all the way to white box testing, where you don't tell us anything about your system. It will first interrogate your system to figure out what it does, craft goals, almost act like a security engineer, start attacking. With every payload, it evaluates whether the payload was successful or failed. If it fails, it improves the payload. If it was successful, it improves its attack goal. And in the end, again, gives you the a full report of where it failed, where it was good, what are the types of attacks that are working, what are the types of attacks that are not working, how you should potentially fix those attacks and prevent these attacks on your systems. Some examples, right? This is the attack library one. This is a very popular attack known as adversarial suffix, where you add a suffix at the end of your system based on the weights of the model, which sort of tricks it into saying things. So let's say if you say, write a tutorial on how to make a bomb, OpenAI usually would say, sorry, I can't help with this, but with this particular suffix behind it. The first 2 times it failed, but the third time it started giving instructions on how to build a bomb. Right. So this is 2 examples. One is the types of attacks. The second is why you need to send it multiple times, right? Like the exact same string did not work 2 times, but worked the third time. So this is the agent talking with the same system, right? Like, so if we go back, if it goes back, so if you see, it starts having a conversation almost as if a security engineer is having, when based on every response, it improves. So when it found out that role play based attacks are working, it then doubled down that it continued the same role play along with virtual scenario setups to see what is the worst it can get the system to do. So yeah, these are the 2 ways our systems work. I think that'll be the end of my plug. But yeah, what can you do today if you are building or just learning in this space? So if you're a security engineer, security executive in this space, but you're just starting, how do you prepare for AI adoption? So if you're in very early days where your company is just starting to think of how we want to adopt AI, start threat modeling experiments, because in most companies we've talked to, they've started with experiments, right? Like where they're like, let's try these 5, 10 different projects, whichever works out well, we'll take it to production. But in most of these companies, they decide we'll do security testing of only what is going live. Don't wait for that. This will be a good training exercise for your security teams as well. Start threat modeling or any experiment that's going live. That will also teach you how they're building these systems. If the company's already started building these systems, start red teaming them. Don't wait for them to hit production. Think of this as early testing. Again, lots of resources on how you can do that. But happy to connect offline if you're in this phase and want to try out a product as well. And if you're already in a phase where your company has already adopted AI and already deployed, do all of the above, but also ensure you have enough runtime security pieces in place, which includes, let's say, AI firewalls, observability, anything that you can do in runtime. As of today, in AI, runtime security is still something that gives a lot more results than, let's say, design time security. Key takeaways. I don't know if I've covered all the key takeaways from before, but I just tried to cover a few. Securing AI systems is different from securing other systems. I don't know if I was able to convince you on that or not, but I strongly believe that. When it comes to AI, the line between security, safety, abuse, bias, all of those pieces are very blurry, right? So you make sure your company, there's no fights around who owns what. Somebody will have to raise their hand and own it all, right? Like having different people own this doesn't help. And most likely when it goes wrong, security is the people who are going to get blamed, so might as well take the responsibility to fix it. Red teaming is an extremely powerful tool in your journey to secure your AI systems, right? Because it helps you figure out what your current state of things are, where are you susceptible, and then change your strategy as needed. Gives you the confidence that we are ready to go live or not go live. And yeah, automation is your best friend. I don't think red teaming AI without automation is of any use, right? You'll get a false sense of security. You'll just get, okay, as of today, as of this attempt, my system was secure, but I don't know 5 minutes later if it's still secure or not. Yeah, I think that was it. Thank you. I think I saved you the 5 minutes of my introduction, and reach out anytime if you have questions. Sure. Any questions? Sure.
Hello. Yeah.
Yeah.
So in Sidebox, you mentioned, right, you update the payload again, and then you update the goal again.
Mhm.
So these combinations, you keep continuously with the same payload, like same type of attack workflow. So how do you decide, like, this is the worst it can do? Like, when do you stop that?
So you get to set. So this is a customization you get in while you're running your scan. You get to decide how far should it go, right? Like at what time should it? At what point should it give up, right? So we have a default depth and a default breadth on your attack tree. Based on that, it decides how deep will it go. Now, let's say your system could be even more vulnerable, but let's say if you've set the depth to 10 attacks, then it'll stop there. Right.
Yeah, so I will not be able to figure out the later vulnerabilities that still might exist, but I have not adjusted the depth accordingly.
100%. So that is why, like, once you fix those, then you can start increasing your depth. And it also learns from its past attacks, right? Like, so it won't be that, let's say it did attack A, B, and C and found those didn't work and D worked. Next time it won't try A, B, C. It'll just start from the point B.
Okay, but you say that the AI systems transitions, right?
Correct.
So, like, if I won't try the previous vectors, so it should take in consideration of the previous vectors, because if I again try the previous vectors, then again, ideally, it would be possible they might work.
Correct. Great point. So the thing is, none of these attacks are static, right? So it's using different types of techniques and procedures. So even if it doesn't end up using A, B, and C, the techniques that were used in A, B, and C will get used somewhere. Now, let's say if the new attacks are not working, it will start going back to older ones, do a combination of all of them, and then try those.
Okay. Okay. Thank you.
I think there's one here.
Ruchir, quick question on how to detect zero-day. Whatever you showed is published on archive. It's been waited a couple of months.
Correct.
So things like that, the poem example, is there a way to, let's say, detect if the training data is poisoned? Red pajamas.
Again, this will be based on everything that I've read. There is research that's already in that space going on. Like, you can look for the known poisons. For unknown poisons, again, it comes down to extensive testing, but there isn't, unless you have full control of the data that went in, or somebody who had that control is willing to give you that in a contractual way, that this isn't, for example, right, like Cohere, right? Like Cohere's whole selling point is that their data does not contain any copyrighted content, and they're giving contractual coverage for that, right? So if similarly, like whatever model you're taking, if the person who built that model is able to give you that guarantee of the data that went in, that would be the most effective way as of today. But there are ways to look for known poisons. So if you know that these are the types of popular poison data pieces that are within models, you can test for their existence in models. But the unknown poisons is still an semi-unsolved problem. Thanks.
Yeah.
This is mainly with respect to the runtime security aspect of it.
Yeah.
So I was wondering, let's say you're typically interacting with one agent, right? You interact with the agent is giving a response. Right before the response is probably shown to the user, why not have another agent which should probably validate if the response is as per expectations?
Sure. And I'm assuming when you say agent, you're talking about an LLM agent, right? So that is a fairly common method, right? Like where there is an input guardrail and an output guardrail. Now, that output guardrail could be built using LLMs as well. A lot of things come down to what is your most accurate way of doing it, and reducing your false positives, reducing your costs, reducing your latency. So that is one of the ways you could potentially do it. But just protecting the output may not be enough, especially when your input could lead to taking some actions which don't even lead to like an output coming, or leading to, let's say, the output itself being something that can then trigger a injection or a jailbreak on the output LLM. So best is the defense in depth, right? Like, so you ideally want to protect your input and your output.
Thank you.
Cool. Thank you so much.
Thank you.